grade 12 learners, welcome to today's technical mathematics lesson. My name is Matsiriso Kongwane. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Remember, our WhatsApp number is 079-578-2908. You are more than welcome to send your clarity seeking questions to that particular number. Repeater the number 079-578-2908. Okay, grade 12s today we'll be looking at the Euclidean geometry, and then specifically we'll be looking at the circle geometry. By the end of the lesson, you should be able to apply circle theorems and their converses in the calculations to solve geometry problems, and then you must also provide reasons for all your statements. And then the pre-knowledge that you need your grade 10 knowledge of a straight line geometry. And then we know that when you have angles on a straight line, adjacent angles on a straight line are supplementary. Supplementary means what? They add up to 180 degrees. So in this case, we have angle A1, angle A2, and angle A3. If you add those three angles together, your answer must be 180 degrees. Why? Because they are angles on a straight line. Okay. And then now, if you look at angle A, B, C now, they are not on the straight line anymore, but they are angles around the point. Angles around the point, they sum up to 360 degrees. That means if you revolve anti-clockwise up to this point, from this point up to that particular point, that is why we say angles around the point, they add up to 360 degrees. We also apply this in trigonometry, where we are revolving from 0 degrees, moving to 90, 180, 270, up to the line of 360 degrees again. That is why that angle, when you revolve from 0 to, it is called 360 degrees angle, because it's an angle around a point. And then the third one is vertically opposite angles. And then when angles are vertically opposite, they form V to each other. Can you see that V? That means A and C, they are vertically opposite to each other. And then they form this cross here, and then they are inside those V. So angle A is equal to angle C, and also angle B will be equals to angle D, because they are vertically opposite to each other. They are exactly equal. If this one is 30 degrees, that means this will also take a 30 degrees. And then if you look at A and B now, they are on the straight line. If you add A plus B now, you will get 180 degrees, because they are angles on the straight line. And then we have the value of B, which is equal to 30 degrees. 180 degrees, basically the value of A will be 180 minus 30 degrees, which is 150 degrees. And then if that is 150 and it is vertically opposite to C, that means C will also be 150 degrees. Can you see that C plus D also adds up to 180 degrees, because they are angles on the straight line? 150 plus 30, the sum is equal to 180 degrees. Why? Because they are also angles on a straight line. The vertical opposite ones are exactly equal. Now we are looking at the angles between parallel lines or between your transversal lines. So now we have angles that are identified by the letter F, and then it must be angle inside that F shape. This F can face any direction, later. It can be in this direction, it can be that direction, as long as you are having parallel lines in between them. It can be an F facing to the left there. It doesn't matter in which direction does your F face. And then now that is where we take the corresponding angles out of the F shape on condition that you are having parallel lines. Therefore, this will be your corresponding angles inside the F shape there. In this case, on the given one here, that is why we are saying BAC, that is BAC is this angle here, is equal to angle DCE, DCE, that means you are talking to that particular angle there. They are exactly equal. If this angle here is equals to 90 degrees, that means this will also be 90 degrees, exactly equal. All right, and then now let's look at the U shape now. In order to remember this grade 12, we are using the abbreviation FAN. F for corresponding, U is for co-interior, and then Z is for alternating angles. The same applies with the U shape. It can face any direction. It can be a U facing down, a U facing to the left, or a U facing to the right. As long as we are having parallel lines in between. Therefore, those are the angles which are co-interior angles. And then in this case now, let's look at the angles. We are having B1 plus C1 equal to 108. Remember, with the corresponding angles, we said they are exactly equal. But in the case where we are having the co-interior, where you get your co-interior, it is inside your U shape there. This is co-interior to that one, co-interior to that one, co-interior. That means when you have your U shape, we are taking the angles inside that U. When you add these two angles, they must always give you a 180 degrees. They are not always equal. It's fine, they can be 90, 90. Yes, because 90 plus 90 is 180. But that is not always the case. It can be 120 and 60. It can be 180, as long as the sum of the two is 180. Therefore, those two angles are the co-interior angles. And if they are in between the parallel lines, the sum of them must always give you 180. And then now with the Z shape or the N shape, this one can also face any direction. It can be like that, or it can be in that format, or it can be in this way. As long as it is between the parallel lines, then those are the alternating angles. And then what about alternating angles? Now, we are talking to the angles inside that Z, okay? And then that means angle B1 is equals to angle C1, exactly equal. If this angle here is 20 degrees, that means the C1 will also be 20 degrees. They are exactly the same. That means the corresponding and the alternating are exactly equal. But it's only the co-interior, when you add the two angles, they give you 180 degrees. And then now you also need the knowledge of triangles. We are having different types of triangles, and then this is classified according to the sides for these ones. So now the first will be an equilateral triangle. How do you know that a triangle is equilateral? It's when all the sides are equal. All the sides of that particular triangle are equal. Therefore, this triangle is an equilateral triangle. Now, out of that information of all the sides are equal, if all sides are equal, that means all angles must be equal. All interior angles of that particular triangle must be equal, because they are all opposite equal sides. Now, basically, we know that the sum of angles of a triangle are equals to 180 degrees. So now in this case, that means angle R plus angle S plus angle T, the sum of that is equal to 180 degrees. Reason it's sum of angles of a triangle, or the interior angles of a triangle. So now, Since all these angles are equal, out of the 180 here, we divide by 3 because we are having 3 angles that are equal. So this will give us 60 each. That is why we are having each value of an angle here in an equilateral being a 60, because it must add up to 180, whereas they are all equal. That is where this 60 degrees comes from. It comes from the 180 sum of a triangle. And then we have an isosceles triangle. In isosceles triangle, only 2 sides are equal. As you can see, it is indicated that this side is equal to that one, and the angles opposite those equal sides will be the one that are equal. That is why S is indicated being equals to T there. Why is because they are angles opposite equal side. Angles opposite equal sides. Okay, so that is it in isosceles. 2 sides equals, and the angles opposite equal sides, they are also equal in an isosceles. So that means if they can tell you that a triangle is an isosceles, you can indicate that the 2 sides are equal, and it must also have somewhere the base angles or angles opposite equal sides being equal. Okay. And then now we have a scaling triangle. With the scaling triangle, all sides are not equal. No sides equal. Every side is having its own value there. And then that, if that is the case, also the angles, each and every angle will have its own value there. But still, if you add these values, that dot, that cross, plus this open dot there, the sum will always be equal to 180 degrees. All triangles, they sum up to 180 degrees. Okay. So with scaling, no sides equal, no angles equal. And then we have triangles that are classified according to angles now. If it is an acute triangle, that means the angle here must be less than 90 degrees. As you can see, remember when you have 90 something like that, the minute you do that, it is now less than 90. That is an acute angle. And then now when you talk obtuse angle, an obtuse angle, it must be between 180 and 90 degrees. It's an angle between 180. If you calculate from the origin there, you pass the 90 degrees. Can you see that? Because our 90 will be somewhere there, the 90 degrees line, and then we have the 180 degrees line. That means now when we talk obtuse angle, it's an angle between what and 90 degrees and the 180 within this region there. Okay, it must be in that triangle 90 and 180. In the quadrant 90 and 180 when you compare to your quadrant. And then now the right angle triangle, it's a 90 degrees triangle. There must be one angle being at 90 degrees, only one 3/12. And then now as you can see, angle B here, it have a curve that is indicating it is a 90 degrees. As long as you have one angle being at 90 degrees, that is a right angle. If that is the case, that means A plus C will also be a 90 degrees, because now sum of angles of a triangle is 180. If you take this B value out, being 90 degrees, so the remaining angles A and C will take the remaining 90. That is why we can conclude that the sum of this will be 90. Although we are not sure whether it will be 20 and 70 or a 45 by 45 or a 30 by 60. But the values of A and C will add up to 90 degrees. It can be less or more than that. Right, and then now we are still on triangles. Now the interior angles, I've already talked to this. The interior angles of a triangle are supplementary. That means when you add them, they give you 180 degrees. Supplementary means 180 degrees. So now that means angle A plus angle B plus angle C is equal to 180 degrees. And then now the next one, the exterior angle. of a triangle is equal to the sum of the two interior opposites. Now this is the exterior grade 12. So now you can't take this one because it is straight line to that one. So when you talk two interior opposite angles, it must be this angle plus that one. So these two is equal to the sum. The exterior is equal to the sum of the interior opposite. That means we add angle A plus B, they will be equal to angle ACD. So angle ACD is equal to the sum of the two interior A plus B. And then theorem of Pythagoras, now you cannot apply Pythagoras if you don't have a 90 degrees triangle. Firstly, you must check that the triangle that you are having is a 90 degrees one. There must be a curve that is showing that this is 90. It's only then that you can apply Pythagoras. What does Pythagoras state now? It says now the hypotenuse side. Which side is the hypotenuse? That is the side opposite the 90 degrees. This is our hypotenuse side. A side opposite 90 degrees. So the square of that particular side now, the square of that particular side, that means the square of AC squared is equal to the sum of the other two sides, being the adjacent or hypotenuse to this angle or to angle A there. And then now those sides are what? The AB squared plus the BC squared. Corrections to that one, grade 12. You must start with the hypotenuse, which is AC squared is equal to the sum of the other two sides squared. Okay? That is the sum of AB squared plus the BC squared. But the main side is the hypotenuse side, which is your AC squared for this particular triangle. Now, you also need the pre-knowledge on congruency. And the symbol for congruency, we are using this dash. Can you see the three dashes there? And then they must be horizontal. If they are vertical, now they are talking to similarities, no more congruence. The congruence one must be vertical, must be horizontal, sorry. If the two triangles are congruent now, if we say two triangles are congruent, it means that they have the same corresponding angles and the sides in each triangle are exactly equal. For example, the example of the real life situation of congruency is your hands. If you match them, they match the sides the same, and the corresponding angles of your fingers will be the same. Then that is the type of the real situation congruence that we are talking to. And then now, that means the size of angles and the size of the sides must be exactly equal to be congruent. And then now we have conditions that are making two triangles to be congruent now, of which we are having 4 of them. The first condition is that if you are having two triangles and these triangles now, all sides are equal, 3 corresponding sides are equal, then the two triangles are incongruence. They are incongruency. And then now the reason for that will be side, 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 because now you have indicated that this side is equal to that one. This one corresponds with that one are equal. And then now we are having the last one being equal there. If that is the case, you can prove to us those sides are equal. Therefore, you can conclude that these two triangles are incongruent. And then now reason will be side, side, side. Second condition, if the triangles have two corresponding sides and included angle equal, two corresponding sides equal, and the included angle. What do we mean by included angle? It must be between the sides that are equal. For example, here we are having this side equal to that one, this side equal to that one. So included, it must be between the equal side in the two triangles. It must be between the equal sides. You can't take, for example, if I'm having a triangle here, and then another one, and then this side is equal to that one, this is equal to that one, and then I'm having an angle which is equal to that one. These two triangles are not congruent because they must have what? Included. The angle must be included. It must be between the equal sides, not there, to be congruent. I hope that is clear, grade 12. It must be two corresponding sides with an included angle. And the reason for that will be side angle side. Side angle in between and another side. And then now the third condition is the hypotenuse and the other corresponding side must be equal in a right angle triangle. Number one, the two triangles must be right angle triangle. For the hypotenuse, because you can't have a hypotenuse where there is no 90 degrees. Remember, hypotenuse is a side that is opposite the 90 degrees. Hypotenuse is the side that is opposite the 90 degrees angle. And then now that means that hypotenuse side, the side opposite 90 must be equal. And then the other corresponding side must be equal. It doesn't matter whether it's this one or that side. And then now, remember, you'll be having now hypotenuse, you'll be having a 90 degrees and the other side. Then these two triangles will be congruent. And the reason will be what? Right angle for 90 degrees, hypotenuse and the side. Sometimes they write it as a 90 degrees hypotenuse and the side. It is also acceptable, grade 12. And then lastly, if triangles have two corresponding angles now, two angles corresponding equal and one corresponding side equal. In this case, you must have two angles corresponding equal plus corresponding side equal. Now it can be angle, angle, side, your reason, or side, angle, angle, or angle, side, angle. That means now if I'm having this equal to that one angle, and then this angle now being equal to that one, and then this corresponding side. Why do we say it's corresponding? In both triangles, it is between the equal angles. Then this condition is angle, side, angle. Angle, side, angle. Okay? And then for the second condition, can you see that this angle is equal to that one? And then we are having that angle which is equal to that one. We have that side equal to that one. Can you see now you are having angle, angle, side, and angle, angle, side? Because now the side is opposite this double dashed angle, and also this one is opposite the double dashed angle. Exactly at the same positioning in both triangles. Then is the angle, angle, side. Or you can say side, angle, angle. It's fine with us, grade 12. Anyhow, you can write as angle, angle, side, side, angle, angle, or angle, side, angle. It's fine. But be careful, it must be corresponding angles with the corresponding side. And then now similarity. Do not confuse the two. Remember, with congruency, it must be horizontal lines. With the similarity, it is the vertical three lines there. And then now for the condition of similarity now, when two corresponding angles are equal, two corresponding angles must be equal. The third angle is automatically equal. For example, grade 12, if this angle is equal to that one, and this is equals to that one, that means the angle C is equal to F automatically. How do we know that one? If this angle is 20, that means it's also equals to that one being 20. And then if angle B here is equal to 70, or let's say 80, angle E will also be 80 because it's given being equal. Look at that. You still remember that sum of angles of the triangle are 180 degrees. That means now this angle will also be 80 here, because now it must give us the sum of 180. The same apply, 20 plus 8 is 100. That means F will also be 80 degrees. That is why we take this conclusion that if the two corresponding angles in two triangles are equal, the third angle will be automatically equal. You can just tell us that they are equal without even testing. if it is given that the two angles are equal. Now, in order for two triangles to be similar, they must be equiangular. Equiangular means they must have equal corresponding angles. All angles must be equal. So in this case, we are given that angle A is equal to D, that was given to us. Angle B is equal to angle E, that was also given. And then we have concluded that therefore, automatically, angle C will be equal to angle F. Why? Is because of the sum of angles of a triangle, or because of the interior angles of a triangle. And therefore, triangle ABC is similar to triangle DEF. The reason be angle, 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 or you can write with notation of angles with LLL, or you can write equiangular. For us, it's fine. Those are the three acceptable ways of noting the reasoning for that one. So that is how you prove similarity. You must ensure that you have equal angles. And now grade 12. With equiangle, remember with congruency, the triangles are exactly equal in size. The sides are equal, and then the angles are also equal. The difference is that with similarity now, you can have different sizes of triangles as long as the angles are equal. Therefore, the two shapes are similar. So condition for similarity only depends on the equal angles, not equal sides. Okay, equal angles. But you know that when you look at geometry grade 12, the sides must be in proportion, not equal, but in proportion, in order to apply similarity theorem of grade 12 in Euclidean geometry. So now for similarity, we are guided by equal angles. And then now another condition of similarity, I've already talked to that one, that the sides must be in proportion. All three pairs of corresponding sides must have the same proportion. For an example now, let's look at this. We have the smaller triangle and the bigger one there. And then in the smaller triangle, we have AB, which is the smaller side. AB is the smaller one. It will be over, when you are checking the ratio now, the smaller side of the bigger triangle is side DE. That is why we say AB over DE there. And the value is 5, and the DE is 10. Substituting the values, then this will give us a ratio in a simplified fraction 1/2. And then now we check another side now. Which one follows? It's AC. After 5, the next bigger one is 8. Then it will be AC over DE, 10 followed by 16 in this case, right? Goes with that one. And then now it will be AC over DF, which is 8 over 16. Simple fraction give us the same thing as the previous one, which is half. Lastly, we are taking the biggest, the longest side now, that is BC over EF, that is 10 over 20. Substitution, simple fraction is 1/2. Can you see grade 12, we are getting the same ratios for all the fractions. Therefore, those sides are in proportion. They are all equal to 1/2, same ratio. So if they have the same ratio, that means these two triangles are similar. Reason being, sides are in proportion. Remember, lastly, we were proving using equal angles. That is why we were saying equiangular. Here we are proving using ratios of the sides. If they are in proportion, that means they are in equal proportion, which is half. Therefore, the two triangles are similar on condition of sides are in proportion. Right, we are still on similarity here. The condition is that ratios of the two corresponding sides are equal and the included angle. In this case now, we are checking the ratio of only two sides that are equal, and then the angle included between those two sides which are in proportion. Then it's only then that you can conclude they are in similar. That is the third condition of similarity. The two pairs of corresponding sides are in the same proportion. That means you are given that AC over DF, AC over DF is equal to the AB over DE. As you can see, that is given as being in proportion there. And then you are also given that angle A is equal to D. Look at the angle. It must be the angle between the proportional side. And then now, therefore, the two triangles are similar. That is another condition. And the reason will be two sides are in proportion and the included angle is equal. You will need this grade 12 when you are doing your similarity Euclidean geometry grade 12. And then here is your baseline grade 12. Please complete this table for me. You are classifying now. We are talking to the grade 11 Euclidean geometry of a circle because you are also going to be tested on that one on your grade 12 paper, even your June exam. So classify these 9 theorems that we are having in grade 11 circle geometry under the center theorems, the cyclic quad theorems, and the tangent theorem. That means your activity is to write down the theorems as per group or classification given below. I'm giving you 5 minutes, grade 12, to classify these theorems for me. Your 5 minutes starts now. Okay, grade 12, let's see how far do you remember your theorems now. Remember to send your solutions to 079-578-2908 or any clarity that you need pertaining these theorems, grade 12. Okay, now remember the first one. Do you still remember? It's a line from the center perpendicular to the chord. That is the first theorem that you started with, grade 12, on circle geometry. And then it is having its converse now. The converse of this theorem, it says line drawn from center to the midpoint of a chord. And then the third one, we are still on center theorems. A perpendicular bisector of the chord. So that is how we abbreviate that. But it's talking to a perpendicular bisector of any line that is bisecting a chord. Any line that is bisecting a chord. As long as it is bisecting a chord, that means this line is perpendicular and it passes through the center. It cannot bisect a chord, perpendicular bisector, without passing through the center. As long as they say this line is a perpendicular bisector of this chord, that means that particular line passes through the center, grade 12. That is the conclusion that we can conclude with this theorem now. So please check that. It's also on the center theorems. And then we have angle center, which is twice the angle at the circumference. Lastly, we are having angle or angles in semicircle. Or you can write it as angles in half circle. It must be a circle with a dot to show that it's a circle, not O, not 0. It must be a circle with a dot to show that it's a half circle. You cannot just write O or write as 0 there. And then these are the center theorems, grade 12, so you must remember them. That means when you attack your rider, you check whether you have a center. Yes, then you check these theorems. And then now the second class here, we are having the cyclic quadrilateral theorems. And then this one, we are having angles in the same segment. And then we have equal chords, equal angles. That means now if we are having equal chords, they subtend equal angles and the circumference at the center of your circle. And then now thirdly, we are still on cyclic quad, opposite angles of a cyclic quad. Are supplementary or they are equal to 180 degrees. And then now, lastly, we are having exterior angle of a cyclic quad. Remember, you just write this abbreviation. We know that this is equal to the interior opposite angle. The minute you write exterior angle of a cyclic quad, we know that in full it is saying to us it is equal to the interior opposite angle. And then we have tangent theorems. The first one is tan perpendicular to radius or tan perpendicular to diameter. Okay, is tan perpendicular to radius or a tan perpendicular to a diameter. And then now we also have tan from the same point or tan from common point. They say tan from same point, or you can say tan from common point. It is more than one tangent, is tangent, two lines from the same point or one common point. And then lastly, we are having a tan-chord theorem. Grade 12, basically you must know these theorems by heart and how to classify them, and then the shapes of each theorem. How is it represented in terms of a diagram? Okay. Now the terminologies that we'll be using here, we are going to talk to the radius. A radius is a line from the center of a circle. This is the center, a dot. You'll be having a circle with a dot. That dot is indicating the center. And then a radius is a line from the center to the circumference. Circumference is this outer part of your circle here. That round part, you call it the circumference. The outer part of your circle is the circumference. So a radius is from the center to the circumference of the circle. We call it a radius. And then a diameter is from one side of the circle, but it must pass through the center to the other side of the circumference. That simply means now to form a diameter, you can see you have a radius, two radius joined together, because there's a line from center to circumference, center to circumference. If you join them, they form a diameter then. And then a chord is a line from the circumference to the other side of the circumference. If you look at the difference between this one and the diameter, is that the chord doesn't have to specifically pass through the center. Any line that is from circumference to circumference inside the circle is a chord. That means the diameter is also a chord because it's from the circumference to the, but it's a special chord because this one passes through the center. And then now we have a tangent. A tangent is a line that touches a circle at one point of contact. Can you see that outside there? The line that touches a circle once, it's a tangent. If you're having a circle and a line like that, it's not a tangent. It must touch the circle outside at one point of contact. And then a secant is a line passing through 2 points on the circle. It passes out of the circle. Can you see that the difference between the chord and the secant is that a chord is from the circumference to circumference. It can't pass those points. It stops there on the circumference. But with the secant now, it's a line that is passing through the circle continuously. As you can see, it's having arrows there. It's a continuous line, but it passes through 2 points on the circle. Then that is the secant. Okay. So those are the terminologies, grade 12, that we'll be using. And then we have an arc. Can you see that this is the minor arc, the smaller one? And then we are having the bigger arc in black there. That means arc is a partial part of your circumference. We call it an arc. And the secant, as you can see, that shaded yellow part, when we cut off that one, when you are forming a cone, then this is a sector. We take out a sector to form a cone. You've been doing this grade 12 when you were doing your PET project 1. And then now the general hints when solving Euclidean geometry now, you must read the statement twice and ensure that all given information is indicated on the diagram. Sometimes the information is on the statement but not indicated on the rider that is given to you. So now you read twice to ensure that everything that is on the statement is indicated on the diagram. And then analyze and note down all theorems now. You'll be, as we have classified them, the first thing you check, is there any center? Then you check the center theorems that are applicable there. Is there any cyclic quad? You check the cyclic quad theorems. Is there any tangent? Then you check, note down all the theorems that you see on that particular rider. And then now use different colors to mark off equal angles and the sides as you are analyzing your diagram. And then start from the given angle to track to the solution. The given angle will always assist you to find the unknowns. And then after calculating any angle, put the information into the diagram because it might lead you to solve the next problem. So these are the hints, grade 12, that you can take with you when you are solving your riders. Now let's start with the first lesson now. Let's go through the statement as we've indicated. In the accompanying diagram, M is the center. Yes, we have M there being the center of the circle. AB is the chord with the length of 8. So from A to B, we are having the length 8 units. And then now MQ is perpendicular to AB. Yes, it is indicated there. And then AP is 12. A to P there is given as 12 there, yes. And then PT from P to T, not the whole side. PT only is 8 units there. So the misconception is that most learners, they will be thinking that 8 is for the whole of PM. That is why it's important to read the statement to ensure that 8 is only for the PT part, okay? And then now with T, a point on the circle. And then MQ is 3 units. The MQ side is 3 units. That is indicated. That means now, grade 12, all the information on your statement is indicated on the diagram. After verifying that now, you look at the diagram, try to identify which theorems are here now. We are having a line from center perpendicular to the chord. Can you see the theorem? Then you note down the theorem. So I'm having angle center perpendicular to the chord. Okay, that is the only thing that we have. And we know that if we are having the 90 degrees, that means Pythagoras can be involved there because we have a 90 degrees triangle. Yes, now we have analyzed the diagram. We can now start answering the questions. Write down with reasons the length of AQ. It says write down. That means the answer is somewhere there on the given information. So now they say write down the value of AQ here. So we are given that AB is equal to 8. So we can conclude for 1.1 that AQ is equal to BQ. That means each will take a 4 out of 8 there. Why are they equal? It's because of the line drawn from center perpendicular to the chord, because it is given as 90 there. If you are given 90, your answer must talk to, the reason must talk to perpendicular there. After calculating the value, you can bring it into the diagram now. Okay, this is 4. And then you have 2 marks, that is 1 for finding the 4 value and 1 for giving the correct reason there. And then with 1.2, determine the length of AM now. We want the length of AM, this side. And this side now is on triangle, is in triangle AMQ. So in this triangle AMQ, AM is the hypotenuse side. All right, that means we can apply Pythagoras because we have the values of the other 2 sides. What is the hypotenuse side? AM squared is equal to the sum of the other 2 sides squared, AQ squared plus the MQ squared. Why are we saying this? It's because of the theorem of Pythagoras. For every statement, there must be a reason in Euclidean geometry. And then from here now, because we are looking at the AM, if this side loses an exponent, this will gain a square root. And then now we are also substituting the AQ value, which is 4 calculated above, plus the MQ value given as 3 squared. And then from here now, grade 12, you can put everything into your calculator straight to the answer. That means side AM will be only 5 units. That means this is 5 units then. Then 3 marks, it's 1 for substitution into the correct Pythagoras theorem, and then for your answer and for your reason there. That is how we allocate that 3 marks. And then remember, we have already calculated above, this is 4, this is 5. Now, let's attempt the next question. 1.3, prove that angle PAM, this angle here, is equal to 90 degrees. That means we are actually proving that this triangle PAM is a right angle triangle because we are proving 90 degrees. So the examiner can say prove PAM is angle PAM is 90 degrees, or prove that triangle PAM is a right angle triangle. It's the same thing, grade 12. Now remember, to be a right triangle, that means the square of the hypotenuse side must be equal to the sum of the squares of the other two sides. Now let's check now the value of the square of hypotenuse. What is the hypotenuse side squared here? Our hypotenuse side is the PM side. Now, grade 12, we have a challenge. We have PT, remember, being 8, and then we need PM. And then now we need to have the value of Tn. So we are going to start by saying, okay, Tm is equal to Am. Why? Because it's a line from the center to the circumference, from center to circumference. It's because these are radii. And that means this will also be 5 units. So this is also 5. Therefore, now we can conclude that Pm will be equal to 8 plus 5, which is equals to 13, correct? So now we are having the hypotenuse side squared. Which side is the hypotenuse now? The hypotenuse side is Pm. Let's find the value of Pm squared now. Pm is 13, so if you square 13, you end up with 169. You cannot conclude yet that they are equal, grade 12, because you are testing whether the hypotenuse is equal to the sum of the other two sides squared. If that is the case, therefore this triangle is a 90 degrees triangle. And then let's take the sum of the two sides now. What is the two sides? It's AP. If we can square AP and add it to AM squared, if this can give us the same value as 169, that means this is a 90 degrees triangle. How much is AP? That is 12 squared plus the AM, which is 5 squared. 12 squared is 144, and the 5 squared is 25. And then 144 plus 25 is 169. Can you see, grade 12, that the PM squared is also 169, is equal to the AP squared plus the AM squared. Why? Because they are all equal to 169. We have just calculated that. If that is the case, therefore, angle PAM is equal to 90 degrees. This concludes that triangle PAM is a right angle triangle. Okay, so now we have proven that that is true. PAM is 90. And then now let's look at the mark allocation. For that one is for finding the 5 unit with the radius for the other side. The second mark for finding 169 of the hypotenuse. The third mark for finding the second 169 for the sum of the two sides. That is the third mark. For the last mark is for the comparison. And then now you must give us the reason, grade 12. Why are you saying PAM is equal to 90 degrees? It's because we are using the converse of Pythagoras theorem. Then you mark your conclusion. It will be 1 for radius, 1 for the first 169, for the third one, for the conclusion, and for showing that the sums are equal. Okay, that is your 5 marks. And then now, grade 12, I want you to try again the center rider on your own now. This is worth 5 marks. And then applying the method that I've shared with you just now. And then you are having 5 minutes to do that. Your 5 minutes starts now. Okay, grade 12s, remember our WhatsApp number 079-578-2908. You can send your alternative solution to that platform or any clarity seeking question from your side. Now, remember, the skill around this is that you read the statement and show everything. As you can see, your diagram is clean. There is nothing indicated there in terms of the values now. So we need to go through the statement in the figure. Both circles have center O. They are sharing the same center, the O. The radius of the smaller circle through P is 17 millimeters. So the radius through P there, then you need to bring that. This is the only theorem that you can construct lines, okay? You are not allowed to add any lines in other theorems. It's only the line drawn from center that you can draw your radii then. And then this is 17 millimeters, and the radius of the bigger circle through Q now, we are taking this to Q, and then this is 25 millimeters. And then OM is perpendicular to MPQ as it is indicated there, grade 12. That means which theorem is that one? It is automatically telling you that it's a line from center perpendicular to the chord. That means now you can also apply your Pythagoras theorem. If this angle is 90, this is also 90 in both triangles OMP and OMQ. So you can also apply your Pythagoras. Now, the length of OM is given as being 15. Can you see now you have two values in smaller triangle and the two values in the bigger triangle. Then the question says, determine with reason the length of PQ from here to there. That means grade 12, if you can calculate the whole length of the bigger triangle and then the length of MP in a smaller triangle, you can say bigger minus smaller, then you'll be left with the PQ. So you need to analyze your questions before you answer. So that means now we need to find the length MQ in triangle OMQ. Which side is the hypotenuse? OQ. Squared is equal to which other two sides? The OM squared plus the MQ squared. And then how much is OQ? 25 hypotenuse side, and then equal to the OM. OM is 15 squared plus the MQ. We are looking for that MQ line. And then we have MQ losing exponent this side. And then if it loses exponent, the other side will gain a square root. So we are having 25 squared, 15 squared to this side will be minus 15 squared. And then you can put that into your calculator, grade 12, straight to the answer. And then now we'll end up with the value of the MQ side is equal to 20 millimeters. Even if you don't indicate the units, grade 12, you won't be penalized for that. We are interested on the value of that side. That means the whole of MQ now is equal to 20 millimeters. And then now in the smaller triangle, OMP, in triangle, OMP, and okay, you can even redraw those triangles if you feel confused when they are mixed up like that. You can extract the triangle, and then you're having the hypotenuse 17, that is OMP, the smaller triangle, right? And then this is a 90 degrees triangle. Which side is the hypotenuse side? OP squared is equal to the sum of the two sides, OM squared plus the MP squared. And then how much is OP? 17 squared, the OM 15 squared plus MP squared. So MP squared is equal to 17 squared minus the 15 squared. Okay, because 15 to that side changes to minus. And then the MP will lose an exponent 2. This will gain the square root of what? 17 squared minus 15 squared. Into your calculator, grade 12, what is the value of MP? Is 8 millimeters. But we are not looking for that. We need to find the length of PQ. Now, to find PQ, we said PQ is what? It's when you take MQ, the whole length, and then you subtract the MP. You remove this one. Then you'll be left with PQ. How much is MQ? MQ is 20. The MP is 8. That means now you are left with what? With 12 millimeters for the size of PQ. Then that is how you calculate that, grade 12. Okay. And the mark allocation will go substitution and the answer, substitution and the answer, and your answer there. You must give the reason that you are using Pythagoras theorem. Do not forget that, grade 12. Every time you use Pythagoras, indicate the reason. Okay, moving on, we are given a diagram here. And then if you look at this diagram, before I can even read the statement, I can look into the diagram. Oh, I have a center here. Remember, we have theorem, center theorems. It says now, line from center to the chord perpendicular. We don't have that condition. You check the next condition. Angle at the center, twice angle circumference. Yes, we do have angle center circumference. So you note down, okay, I'm having angle center is twice angle circumference. And then now let me check other center theorems. Diameter, do I have a diameter? Yes, PQ is a diameter because it passes through the center. That means I will have angle in half circle or angle in the semicircle. It's applicable here. I'm checking, I have that bow tie shape, which is forming something like cyclic quad. Okay, I will be having the same segment, angle in same segment. Can you see, grade 12? I have identified the theorems that I might have. And in cases where I'm having a triangle, I will also check some of angles of a triangle. I will check whether it's an isosceles angles opposite equal side, especially where I'm having radii like OQ and OP. You can see that is an isosceles triangle. So angles opposite equal, those sides will also be equal. Then I have analyzed my diagram. I know what is happening in that particular diagram. I cannot test the tangent theorem because I don't have a tangent line. I won't even look in that class of tangents because there is no tangent here. That means I'm relying only on center theorems together with the segment, same segment. Okay, now I can now read the statement in the diagram. A circle with center O through PQ is through PQRS. And then PR is the diameter. We have already identified that. If it's a diameter, that means it says this angle is 90 here. Okay. And then POQ, angle POQ is given as 114 degrees, as indicated. And then angle SPR is indicated as 32. The values are indicated. And then they say determine with reasons the size of the following angles. Angle PSQ. PSQ, if you look at that, can you see that diagram? Use your colors, grade 12s. It will assist you. You have a diagram of angle at the center, twice angle at the circumference. Angle at the center is O1. It is twice angle at the circumference, which is angle S, or the PSQ. And then now the reason will be angle center is twice angle circumference. Now how much is O1? 114 degrees to angle PSQ. I'm just indicating the same as they've indicated there, but you can also use S because that is the only angle at S. Divide by 2 both sides, therefore PSQ will be how much now? 57 degrees, correct? So now we know this angle is 57 degrees. We have answered the first question. That means it will be for the value and for the reason there. And then 2.1.2, angle Q3. Remember, after calculating the value, put it on the diagram, right? Now we want to calculate Q3. Q3 is this angle here. So now if you look at your bow tie here, can you see that bow tie shape, which gives you same segment? Therefore, angle Q3 is equals to angle P1, which will be equal to how much? 33 degrees. Reason, angles in same segment. So that means this is 33 degrees. We have answered. Number 2 is 2 marks, is for the value and for the reason. And then now 2.1.3, we are calculating angle PQS. PQS, that means PQS is angle Q1 plus angle Q2. We are talking to this angle here. And then now grade 12, we have already indicated that this whole angle Q is equal to 90 degrees. That means now angle Q1 plus Q2 plus Q3 is equal to 90 degrees. Angle in half second. It's angles in half second. And then we are looking for Q1 plus Q2, which is PQS. And then plus Q3, we have calculated 33 degrees equal to 90 degrees. Therefore, the value of PQS will be 58 degrees. That means this angle here will be 58 degrees out of the 90 degrees that we were having initially there. And then now moving on, grade 12, to the next question. We are still on the same diagram. We have already calculated. Let's put in the values that we have calculated. This is 32. And then we have calculated this is 57. And then we have also calculated that this is 58 degrees. And we know from the semicircle that this is 90 degrees. That is the information we have this far from the previous calculations. And then in the diagram, we are still using the same information. Give a reason why is PO equal to OQ. What is the reason, grade 12? Is because they are radii. Both of them, they are lines from the center to the circumference. It's 1 mark for that with double I there. And then 2.3, calculate the size of Q2. Q2 is this part here, is part of 58 now. We want to take it out of 58, right? And then now we have two options to do that, grade 12. We have two options to do that. The first one, we can calculate the R angle to be 57, and then from here you can calculate, because this will be equal to that one, 57. And then if you add this one and that one is the exterior angle there, okay? And then this exterior added to that one is 114 degrees. Can you see that? So we are going to start by saying angle R is equal to angle S, which is equal to 57 degrees. Angle in same segment. And then now we bring in the 57 there, degrees. And then this 57 will lead us to this angle here, okay? So that angle will be how much? 114. Let's see. Okay, let's use the exterior. Yeah, it can also work straight to that grade 12. No need to calculate that. There are so many ways to calculate this. Now, if you look at triangle, let me redraw this triangle here for you so that you can see what I'm talking about. We have this triangle here, we have O12, and then angle O2 is 114 degrees. And then here we have Q3 and Q2. And then now we have 57 for R here. So I am talking to this triangle here. So now if we are in that triangle, we want to take exterior angle, we are going to say exterior O2 of a triangle OQR is equal to the interior angle, sum of the interior R, plus it will be R plus this one. So this one is composed of Q2 plus Q3. Reason is the exterior angle of a triangle. And then how much is O2? 114, 114 degrees equal to R, 57 degrees, plus Q2, that is 32 degrees, plus the Q3 that we are looking for. The Q2, sorry, we are looking for Q2 here, and then Q3 is equal to 32 there. And then now we have 114 degrees equal to 57 plus 32, that is 89 degrees plus angle Q2. And then to find Q2, we are going to say 114 minus the 89 degrees, and then we end up with the 25 degrees, because 89 to this side will be a minus. So that is how you calculate that grade 12. Remember, we have identified the center angles, and then now we ended up with that particular angle. And then now let's look at this activity, the next one. In this statement, it says in the diagram, O is the center of the circle, and then LOM is the diameter. The minute they say the diameter, that means they say to you that angle is 90 degrees. That means they say to you, you are going to use angle in half circle on your calculations. And then ON bisect. To bisect is to cut into two equal parts. ON bisect chord LP at N. It is bisected as indicated by those dashes. Now they are bringing in the theorem and a line from center, bisecting the chord. If it is bisected, it will create a 90 degrees. Do you still remember that? And then T and S are the points on the circle. T and S, they are on the circle. They are just points on the circle. And then on the other side of LM with respect to P, that is just an information. It is not giving us anything. And then the chords PM, MS, MT, and ST are drawn. Those are just chords. And then now MTS is 31 given. That means it is written, it is there on the diagram. And then determine with reason the size of the following angles. We are looking for angle MOS. MOS. If you look at this diagram here is of angle at the center is twice angle at the circumference. This is the center, this is the circumference angle. Then if you look at MOS, angle MOS is angle at the center. That means it will be twice angle at the circumference, which is 31 degrees. Reason angle at the center is twice angle at the circumference. And then therefore this is going to be 62 degrees. So this center angle here will be 62 degrees. 2 marks is for the value and the reason. And then from here now we have indicated the value on the diagram. Calculate angle L. If you look at L now, we are having equal chords. This chord MS is equal to chord PM. The equal chord subtend equal angles at the circumference in this case. That means now if this chord is equal to that one, that means L is also 31 degrees. So angle L is equal to angle T equals to 31 degrees. Why? Equal chords, equal angles. For every statement, there must be a reason. So it's 1 mark for the statement, 1 mark for the reason. Then this is also 31 degrees. Now 2.2, prove that line PM, this line here, is parallel to that line ON. If you look at the given or our analysis, we have already done that, grade 12, because we have just shown that this will end up being 90 degrees both. If, and there's a F shape, do you still remember the F shape indicates the corresponding angles? Therefore, if those angles are equal, then that means those two lines are parallel. But you must give a statement and reason. Why are you saying this is 90? Is because angle P is equal to 90 degrees because it's an angle in half circle or angle in semicircle. And then why are you saying N1 is 90 degrees? Is because of a line drawn from center bisecting to the midpoint, to the midpoint of a chord. And then now, if these two are equal, therefore, line ON is parallel to line PM. Why are you saying they are parallel? Is because the corresponding angles are equal. We don't write converse, corresponding angles, grade 12. It's just corresponding angles are equal. You don't converse for parallel lines. Ne? We do not converse in parallel lines. Okay, the next lesson in the diagram A, B, C, D. A, B, C, D. It's a cyclic quadrilateral. It's a cyclic, it's a circle inside it's a quadrilateral inside the circle. A quadrilateral is a four-sided figure. Cyclic quad, it's a quadrilateral inside the circle. All the vertex of that quadrilateral must touch the circumference. And then with AD produced to F and AB produced to E as indicated on the diagram. And the CD is parallel, also indicated there, to EF. And then angle E is 50, noted there. And then what is not here is that EA is equal to AF. This statement is not indicated on the diagram. That means you need to indicate that EA is equal to AF, okay? AF, EA, this side here, is equal to the AF one, not this one, grade 12, the AF. So what does it mean now? It means these angles are equal in that triangle AEF because they are angles opposite equal sides. Okay, this angle will be equal to that one. So if this is 50, that means F will also be 50. That is true analysis. We have not yet answered the question. Now let's answer the questions. It says calculate with reasons the value of B2. Where is B2? B2 is this angle here. But we can't just go to B2, grade 12s. We need to start somewhere. We need to indicate that EA is equal to EF, because now to get B2, you need D1 to be opposite cyclic. And then you can get D1 if you can find F. And we have already indicated that F is possible to be equal to E. Now, can you see now you need to analyze. You can't just go straight and solve. So you need to start here where you are having angles opposite equal sides. That means you'll say EA is equal to AF. That is given to us. If that is the case, therefore, angle E is equal to angle F, which will be equal to 50 degrees. Why are they equal? Is because they are angles opposite equal sides. So this will also be 50 degrees. And then now, this take us to D1. So D1 is equal to angle F equals to 50 degrees. Why? Because of the corresponding, there's the F shape here. Then the angles below that, they are equal. Therefore, they are corresponding angles between parallel lines CD parallel to EF. This is also 50. And then from here now, we can now calculate the B2. Can you see, grade 12? It's a long journey. And then to find B2 plus D1 equal to 180 degrees. Reason, opposite angles of a cyclic quad. They add up to 180. But we have the value of D1. D1 is equals to 50. So when you take D1 to this side, it will be minus 50. Therefore, this is 130 degrees. So this angle here will be 130 degrees. And then calculate B1. B1 is the angle outside there. And then now remember, exterior, you come in, you pass, and then the next angle will be the interior angle. So angle B1 is equal to angle D1 because it is the exterior angle of a cyclic quad. So this is equal to 50 degrees. Or you can use angles on a straight line. B1 plus B2 is equal to 180, 180 minus 130. Then you'll still get a 50 degrees. It's for the value and the reason there. And then now in this one, we are given in the diagram the circle with center O passes through A, B, C, D. Can you see the vertex? All of them are touching there. And then we see a crossing bow tie there. Therefore, same segment is applicable. We see a center, that means angle at the center, twice angle circumference. We see parallel lines, that means alternating is also applicable. Or the corresponding and the core interior if possible. Okay, now we can now read the statement in the diagram. The circle with center O passes through ABCD. AB is parallel to DC, as you can see the indication there. And then BOC is 110. This angle at the center is 110. The chords AC and BD intersect at E. They intersect here. And then EO, BO, CO, and BC are joined. They are not giving us anything. It's just the statement, that one. And then calculate the size of the following angles now. We want angle D. Remember, it's from known to unknown. If you look at D, that is the center angle, center circumference. D is circumference to center O. Can you see that theorem, grade 12? I've just highlighted in red. That means angle at the center, 110 degrees is twice angle at the circumference, twice D. Therefore, D will be equal to half of 110, or 110 divided by 2, which is 55 degrees. So this is 55. Then calculating, okay, reason angle center, twice angle circumference. It's 1 mark for the value, 1 mark for the reason. And then 3.1.2, we want angle A. Can you see that bow tie shape again? Coming this way. And then now these angles are inside that bow tie. Therefore, angle A is equal to angle D, which is equal to 55 degrees. Reason, angles in same segment. 1 mark for the statement, 1 mark for the reason. And then now 3.13, angle E. Okay, let's put in 55 here. And then we need angle E2, this angle here. We need angle E2, which is that angle, the smaller angle, the exterior angle of that, this triangle here. Okay, but we are given parallel lines here. That means now, if you look at the Z shape here, angle D is equal to angle B1 which is equals to 55 degrees. The reason is alternating angle. They form a Z shape. Alternating angles where we have parallel lines AB parallel to DC. Without parallel lines, you can't write this reason without it. Okay, so now we have calculated that B1 is 55 degrees then. So if you look at E2, that is the exterior angle of triangle AEB, the small triangle there. So exterior E2 is equal to the sum of the interior A plus B1. So the reason will be the exterior angle of a triangle. What is E2 now is 55 for A plus 55 for B. And then that is 110 degrees. So that is the value of E2. This is 110. And then now the last, prove that BE is a cyclic quad. We have already done that, grade 12. We have just proven that E2 is equal to 01 because both of them are equal to 110. And then if that is the case, therefore, BEOC is cyclic. It's a cyclic quad. Why are we saying that? Is because this is the converse of angles in same segment. Can you see the bow tie that is forming? It is forming there. Okay, that is why we say it's a converse of angles in same segment. Okay. And then now the next lesson. In the diagram, O is the center of the circle then. And then K, T, U, V. Okay, can you see those vertex are touching the circumference? 4 of them, therefore that is a cyclic quad. And then we have PKR, it's a tangent, it touches at point of contact K. And then OUV48 indicated, and then KUT 120 indicated. Now we see center, we are going to apply center theorem. We see cyclic quad, we are going to apply cyclic quad. We see a tangent, that means we are also going to apply tangent theorems. That means all theorems are possible here. Calculate with reasons the size of the following. Angle V, we want this angle here. And then to find V, can you see its opposite angle T on a cyclic quad? Therefore, angle V plus angle T, they are equal to 180 degrees because they are opposite angles of a cyclic quad. And therefore, V will be equal to 180 minus the T value, which is 120. And this is giving us how much? The 60 degrees. So this is 60 degrees. The value and the reason. And then now the next one, we are looking at KOU, this center angle here, KOU. And then if you look at KOU, this is the center angle for the circumference angle there. So angle is the center, angle KOU, of which is center, is twice angle at the circumference, which is V, of which this will be 2 into 60 equal to 120 degrees. Reason angle at the center is twice angle at the circumference. So now this is also 2 marks for the value and for the angle. And then now calculate U2. Okay, let's put in the value 120 degrees here. And then now calculate U2. U2 is this angle here. But if you look in that triangle, you can see that you have radius OU and OK. Okay, to find U2 now, we are going to say OU is equal to OK because they are radi. And then now that means angle U2 is equal to angle K3, which is their angles opposite equal sides. If that is the case, that means they are sharing the same value there. They share the same value. So now in the sum of that triangle, we can say now, in order to find U2, we are going to take 180 degrees and subtract 120 and share equally what is remaining between the two angles because they are equal. So that will be 60 divided by 2. That means each will be 30 and 30 here. And ensure that when you add grade 12, they give you 180. And then this is because of sum of angles or the interior angles of a triangle. And then now 4.4 K2. Okay, let's put in the value, or we've indicated U2 30 and K3 30 there. Now we need K2. Let's look at K2. K2 is this angle here. So if you look at K2, K2 is inside this triangle. So we can use the sum of angles of a triangle and subtract all these angles. Then you will be left with K2. So for K2, we are going to take 180 for sum of angles of a triangle, subtract 60 for V, subtract 48 for given angle 48 degrees OUV, minus the U2 30 degrees, we minus the 30 degrees for K3, and then we will be left with only that K2. It's because of the sum of angles of a triangle, or the interior angles of a triangle. And then the value of angle K2 will be equals to 12 degrees. Then this smaller angle here will be 12 degrees. And then it's 1 for the value, 1 for the reason there. And then we need K1. K1 is this angle here. And then it's between a tangent and a chord. So we move to this chord here. And then from the vertex of that chord, we move to the angle. That means now, this concludes that K1 is equal to angle 48 degrees plus the U2, which is 30 degrees. Why? Because it's the tan chord theorem application. So this gives us 78 degrees for K1. So that is our first statement and the reason there. And then now with the next activity, grade 12, A, B, C, D, it's a cyclic quadrilateral. A, B, check that the vertex must all touch the circumference. It's a cyclic quad, therefore cyclic quad theorems are applicable. MK is a tangent, therefore tangent theorems are applicable. AC bisect, to bisect is to cut into two equal parts. That means an angle BCD, this angle here is bisected. That means this angle is exactly equal to that one. If AC and BC intersected, E and BCM is 50. 50 indicated and BEA is 110 indicated. Calculate with reasons the size of the following. We need D2. D2 is that angle. And then if you look at this, this is tan chord to this angle. From a tangent to the chord, and then from this chord, it takes you to that angle. Then it qualifies to be tan chord. We'll say therefore D2 is equal to 50 degrees from C1 because of tan chord theorem. You must write it in full, grade 12, the reason. And then it's 1 for statement, 1 for reason. And the B1, okay, let's put in 50 degrees here. And then we need B1 now. B1 is this angle here. Before we go B1, we must look for the value of A1. That is why we are having 3 marks. So A1 is in the same segment. Look at that bow tie shape with the D. So A1 is equal to 50 degrees from D because of angles in same segment. And then A1 will be 50 also. And then in triangle ABE, remember we are looking for B1, okay? In triangle ABE, sum of angles of a triangle B1, angle B1 will be 180. We subtract other angles in there. We minus 30 degrees, we minus 110. Then we'll be left with B1. And then it's 110, 70 minus 30, that is 40 degrees. Therefore, B1 will be how much? The 40 degrees. And then D1 now. And then we want D1. To find D1, we start by, okay, we can start here, C3. C3 is the same segment as B1 because we have 5 marks, that means it's a long way to the answer. And then C3 is equal to B1 because they are angles in the same segment. So each will be 40 degrees. So happy, this is 40 degrees, but C2 is equal to C3. That means they are both 40 because we just indicated that is given that they are bisected, okay? That is given as being bisected. AC is bisecting, bisect BCD, angle BCD. So now this will be 40, 40, happy now. And then now we want to calculate D1. Remember, we are looking for that angle there. So now D1, if we take the triangle, D1 is equal to, D1 is equal to C2 then. Look at D1 is having a bow tie in this direction now. Your bow tie is going this way. So D1 goes with C2 there. So D1 is equal to angle C2 equals to 40 degrees angle in the same segment. So now this is also 40 degrees. So now it will be 1 mark for this one with the statement and reason, for both statement and reason, and then the statement and the reason, the statement and the reason, of which is 5 marks, grade 12s. And then that is your homework for today, grade 12. You'll do this activity on your own. And I hope that everything will be correct up to this far. Now, applying the center, the cyclic quad, the tangent theorem. If you see one on your diagram, analyze before you answer. And then this is the summary of your theorem: line from center to the perpendicular to the chord, line from center to the midpoint of the chord, perpendicular bisector of the chord passes through the center. And then analyze the center. We are expecting 1, 2, 3, 4 diagrams. You must know all of them to be able to identify in the diagram. Angle in the semicircle, or angle in the half circle, or diameter subtend right angle. And then angle in the same segment, as you can see, they are equal. We have already applied that. Equal chords, subtends equal angles at the circumference and also at the center. Opposite angles of a cyclic quad, they add up to 180. A plus B equal to 180. C plus D equal to 180. Exterior angle, you come in, you pass, the next angle will be the angle that is equal to the exterior. You come in, you pass, the next angle will be the angle that is equal to that one. Tan perpendicular to radius, tan from the same point, the tan chord theorem is also part of your theorems, grade 12s. And the preview of the next lesson, our next lesson will be on the 14th of May 2025 at 2:30 to 4 o'clock, and then it will be still on Euclidean geometry, but we will be looking at the grade 12 geometry, of which is proportionality and similarity application. This lesson was brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Wish you all the best, grade 12. Thank you for joining us today.